All right, Chapter 10, Arbitrage Pricing Theory. Some of you have heard of this, others have not. Before we even begin, I've mentioned the word arbitrage in previous videos. I want to define that now. Arbitrage is the simultaneous buying and selling of securities, currency, or commodities in different markets or in derivative forms in order to take advantage of differing prices for the same asset. Okay, I tried to name my son Arbitrage. My wife wouldn't let me. Arbitrage is super important, not only in finance but in life, right? Many of us are trying our very best to go through life without being arbitraged somehow. All right. For those of you who don't understand what I'm saying, just know that this is like the 500th video that I've made trying to get all these classes online. So just ignore that. All right. Let's talk about what this means. So arbitrage means buying and selling securities or some asset in different markets or in derivative forms in order to take advantage of differing prices. I'm going to talk about just arbitrage in a more general form of just buying low and selling high. Okay. Suppose we have return here on the y-axis and risk here on the x-axis. Very general. Okay, and these are assets. You can think of these as stocks or portfolios or index funds or whatever you want to think about them as. Okay, so notice something here. There's a relationship that exists between risk and return, right? And that relationship has a slope that's equal to the slope of this line. Okay, what happens if all of a sudden another asset, a new asset, maybe a fund, we'll call it asset C here, is placed here in the risk return domain and asset D is placed here? What's going to happen? How many of you would prefer to buy asset C to asset D? I'm going to guess many of you would, right? Why? Because asset D, according to the risk return relationship, asset D is paying way less than it should. It's paying this much when it should be paying this much. And so some of you would prefer to hold asset C over asset D because C is now paying more return for the amount of risk that it should be paying. Asset C is paying this much return when it should only be paying that much. Does that make sense? So what's going to happen? The demand for asset C is going to go up, the price of asset C is going to go up, and the return for asset C is subsequently going to go down. Likewise, the demand for D will be low, the price will be low, and the future return will be high until C and D eventually become arbitraged in a risk-adjusted form to correspond with this relationship between risk and return that we all expect. Okay, so once asset C and asset D have been arbitraged, any risk-adjusted profit has been arbitraged away, some new asset forms, asset E and asset F. What's going to happen? The demand for asset E is going to increase, prices are going to subsequently increase, and returns are going to decrease. The asset F is going to be underpriced because demand is low and future returns should be high. In other words, the difference between where E sits and this line and where F sits and this line will be arbitraged away in a risk-adjusted form until you get everything, any asset. I could do this 100 different times until you get all of these assets here on this line. So notice that the slope, let's call the slope of this line B. Let's call the intercept of this line A, which means that at zero risk, there still exists some return. You can think of that as the risk-free rate. Okay. The intercept is A. The slope of this line is B. And eventually, any risk-adjusted profit that comes from any asset will be arbitraged until that asset lays on this line. Okay. Does this make sense? All right, so think about this. If I were to take the average, there's going to be hundreds, thousands, tens of thousands of assets in financial markets that will go through this process of having risk-adjusted profit arbitraged away. And let's say that there exists some market portfolio, I'll call it M, all right, some market portfolio that has some level of systematic risk. Now notice there's some level of systematic risk because a market portfolio, all the idiosyncratic risk will be diversified away, as we've said in previous videos. So there exists some systematic risk. Let's call that 1, some benchmark systematic risk. The average market return will be over here. Does that make sense? And now watch what we can do. Okay, this is going to be kind of interesting. It's going to reiterate the idea of the CAP-M. If the average return on the market is right here, and it's going to be equal to A times the slope, remember, or I'm sorry, plus the slope, remember y equals mx plus b. Here's the average market return equals A, the intercept, plus the slope B times the level of systematic risk. And we know that that systematic risk of the market portfolio is equal to 1. Okay. Then the formula is the average market return is equal to A plus B times 1, or A plus B. Likewise, the return for the risk-free rate when risk is equal to 0 is equal to just A, or you can think of the risk-free rate as equal to A plus B times 0, which is over here. That just means that the risk-free rate is equal to A. And now for any given asset I have A, B, C, D, E, and F here, but for any asset given asset I can take the following form, linear form. Asset I, the average asset I is equal to A, the intercept, plus B, the slope, times the level of systematic risk where this asset is on. Does that make sense? Okay. Now watch what I can do here. I can substitute, well, I can rearrange equation 1, so B is equal to the average return on the market minus A. I can substitute equation 2 into equation 1 and equation 3, and eventually what I can get is the risk-free rate is equal to A, the average return on any asset I is equal to A, the intercept, the risk-free rate, plus B, right, where B is equal to the average market return minus the risk-free rate, okay, times systematic risk. Notice this is just the CAPM again. Okay, this is the idea for the single factor risk model that is derived by this concept that all risk-adjusted profit and any inefficiencies will eventually be arbitraged away until they lay upon this line that has established the risk-return relationship. Okay, so this is where we're heading. Arbitrage pricing theory is about inefficiencies, risk-adjusted profits, think of that, risk-adjusted profits to be had, inefficiencies being arbitraged away. All right. In the next video, let's talk about what happens to systematic risk.